Hello. We are live with the first webinar of the DevOps Gathering Reloaded. Yeah. I think we must wait some minutes that more members, attendees have the chance to come on board. And yeah, Rainer, very welcome to the spontaneous webinar from your session of the DevOps Gathering that we miss.
Yeah, unfortunately, I couldn't make the session, couldn't do the session at your in-person event because of the COVID situation, but I'm more than glad to do it today. I'm really excited. I'm here in my home office and I'm looking forward to the next hour with topics around serverless and Azure Cloud and things like that.
Yeah, all these modern stuff, yes. Yeah, but it's very important, I think, to look on these technologies to become services quicker to life. That is the mission, I think, that serverless has at the moment, and we see on this crazy time how important it is to get new digital services live.
Absolutely. The cloud is more relevant than ever, especially in these times. We see that running IT services on-prem with your own team, maybe on a low level or low maturity of automation is really a big problem for many companies. The cloud is fully managed and to a very high degree automated. And therefore, it's not that big of a problem if you don't have the people on site who can care for servers and services and things like that. That makes the cloud a really interesting target, especially today.
Yeah, and it's also important for all of us to share services around the globe.
Absolutely.
And if you have your own on-premise installation, it can be a complicated installation mission to make it available in other countries. And I think the cloud is a very good chance that we developed the last 20 years to make digital services around the globe available.
Absolutely.
I think also the topic of your talk today, serverless is the next innovation things to become functionalities quicker available, testable, and have no so many dependencies from one functionality to the others. It don't mean that the complexity is away, but I think you can incremental develop it and make it available. That is the clear mission of these technologies.
Absolutely. Peter, what do you think? It's 3 minutes past 1 p.m.
Yes,
I think we could get ready to start, right? Do you want to welcome our guests before we get started?
Yeah, hello, all our peoples that hear this webinar. I think it is a very hot topic that Rainer shared with us to make serverless functions on the Azure cloud available. And I hope that we enjoy the time. And now I give you the permissions to share your screen and have fun.
I would love to. Thank you. Okay, I will show my screen. And I would ask you to give me feedback whether you see my starting slide.
Yes, we see it.
Very good then. So let's go. Let's also say a warm welcome from my side. Because I'm presenting from home and I'm not standing in front of you in person, I've put a picture of myself on the starting slide so that you know how I look like. My name is Rainer Stropek. I am from Austria, from a beautiful town which is called Linz. I have my own little company which is called Software Architects, and what we do is cloud. Approximately 11 years ago, we founded our company with the sole idea of building software as a service solutions in the cloud. And since then, this is what we have been doing. writing software for the cloud, helping customers to get into the cloud, to transition their business models, their technology into cloud computing. If you want to get in touch with me after this webinar, here you see my email address, here you see my Twitter handle and my digital business card. If you want, rainerstropek.me, you will find all contact data there. You will find links to my GitHub repository, to YouTube, to Facebook, LinkedIn, and every other social media platform that I am available on. So feel free to get in touch if you want to link up with me. Click on the link, and I'm more than happy to expand my network. I would like to spend a few minutes, only a few minutes, approximately 10, talking about some backgrounds. And I would like to start with a question that I always ask myself whenever it comes to a new technology. I ask myself, why? Why should I use it? Why is it relevant for me as a developer or as an entrepreneur running software as a service solutions in the cloud? And I would like to start with this picture here. This picture should symbolize the good old times of virtual machines. In the cloud, we call virtual machines infrastructure as a service, and it's like building your own home. It's building your own house. You are responsible for designing it, and you have a very deep level of control. You can design the interior, you can design how it looks like. You have to make sure that everything works, and over time, of course, you are also responsible for maintenance. To be honest, we don't do infrastructure in the cloud, infrastructure as a service in the cloud at all, because we are a very small team. We have to care for a lot of functions. We have to care for many, many customers out there, and we simply don't have the time that is necessary to spend for maintenance, keeping everything up to date, keeping everything clean and well maintained. This is not our business. This is where we decided 10 years ago we would like to be, a hotel. A hotel means that it's really convenient for me if I have a certain need. I need to sleep in a foreign city, for instance, that I can go into the hotel. I'm quite sure that I will find a nice room. Somebody else cares for the infrastructure. I just consume it. I just consume the service, the platform. This is why it's called platform as a service. In the cloud, something like platform could be a ready-made database, a ready-made web server, a firewall, a reverse proxy, an API management solution. Platform as a service is just like an hotel. A hotel also has a very unique property, a very unique way of business model. That means if I reserve a room in a hotel and I don't use it, I have to pay for it. And that's the same with platform as a service. If I use platform as a service services today, I have to think about how large should my platform be, how many servers, how many CPU, and so on. And how many of them do I need? And I have to pay for these platforms even if I don't need them. And to be honest, as a developer, I would like to not even have to think about how many servers I need. I would like to forget servers at all. If I need a database, I just want to have a database. And it should be the problem of the cloud provider to provide the right number of servers, the right amount of memory, the correct amount of disk I/O, and things like that. And this is exactly where serverless comes into play. Serverless is consuming cloud resources like electricity coming from the plug in the wall, from the socket in the wall. I'm no longer thinking about the big engineering efforts that have to go into the electricity system to make sure that the right amount of electricity comes out of the socket whenever I need it. And this is exactly what the big cloud providers invite us as developers to do. We deliver the application and they care for the servers, for the sizing of the servers, for the scalability, and we don't care about servers at all. Please don't get it wrong. Serverless in the cloud does not mean that there are no servers. There are servers, but as a developer, you simply don't have to care about. If I ask my little niece, she's 5 years old, where does electricity come from? She points to the socket in the wall and says, from there. She doesn't care about the electricity network and the thousands of people who are busy making sure that there is enough electricity available when she wants to, I don't know, view her latest Disney movie. And with serverless, we are my little niece in terms of cloud resources. That's the first idea in terms of serverless compared to platform as a service and infrastructure as a service. The next important topic that is relevant when we talk about serverless is microservices. There has been a trend towards not building huge monolithic systems anymore. Monolithic systems where in a single monolithic system, hundreds or even thousands of developers contribute to the same code base have shown that they are not very flexible, and it's kind of risky in terms of deployment and so on to have a single point where all the hundreds of thousands of developers contribute to. Microservices mean that we split these large, huge monoliths up into smaller monoliths that we call microservices. A single microservice is not a tiny little software. It's a relevant piece of software that, this is at least my definition, that a single agile team is able to develop, to maintain, and to run. This is what a microservice is. And microservices are really perfectly suited for serverless functions, and I will show you demos later on so you understand what I mean with that. The next important concept that we have to keep in mind when talking about serverless functions is reactive programming. Remember all these microservices. I go one step back. These microservices, this diagram here should symbolize that some microservice, maybe this microservice here, would like to trigger some functionality over here. Then it passes on a kind of message through some kind of message protocol in order to trigger a functionality or to tell another microservice that a certain event has happened. And we call this reactive programming. Reactive programming means that we have a very loosely coupled microservices that do not directly, immediately synchronous communication between each other. They do asynchronous communication between each other. They are passing on messages and events. And this reactive programming model is also something that is very commonly used when it comes to serverless programming. Why? We will talk about that later when I show you some demos, how Microsoft implemented that in Azure. Last but not least, I would like to bring in another important theoretical concept or methodology, if you want. That's the methodology of DevOps and autonomous teams. Nowadays, modern organizations, they organize themselves in autonomous teams where each team can decide about which technologies they would like to use. So when it comes to serverless, it's important that the developers have the freedom of choice of technology. If one team would like to use Python, they should use Python. If another team would like to use .NET Core, they should use .NET Core. And if the third team would like to use Node.js, they should use Node.js. The autonomous teams can choose the technology that they want and build the functionality that they should build. And the important thing that comes in when we talk about serverless is that these autonomous teams should be able to focus on building value from the customer's perspective. No autonomous team is paid by customers to maintain infrastructure. We don't get paid for backing up databases. Our customers simply don't want to care about that, and we won't want to care about that. We want to build software that our customers really care for. We want to build value from the viewpoint of our customer. And this is what serverless should allow us. We should forget about infrastructure. We should forget about server sizing and things like that and focus on the application layer. This is what serverless promise, and we will see whether the Microsoft Cloud can fulfill this promise. Do we have drawbacks too? Of course. There is no platform in IT. I do that for 25 years and I know that there is no platform in IT that only has advantages. There are disadvantages too. And this one is the most important. Build my code, I package it up, maybe in a Docker container, maybe in a zip archive or whatever, I throw it over the fence to the cloud provider and I say, just run it. I trust you. I trust you that you will provide the necessary servers and resources and disk and network and so on. And if I have heavy traffic, please care for a lot of servers. And if nobody is interested in my app, maybe it's in the middle of the night, then I don't want to pay anything. So make sure that all the servers are deprovisioned and I don't need to pay for any servers. That means trust, because I am no longer in control. I can focus on my application layer, but I have to have trust with the cloud provider. And that's a difficult one. Trust has to be earned. Trust is something that you cannot prove. It's something that the big cloud providers has to prove to us that this really works. For us, Azure is a really nice place to be. We have been running applications on platform as service serverless for many, many years in the Microsoft cloud. We have this trust to Microsoft. You have to decide on your own whether you trust the cloud provider that you would like to choose. Can it be maybe Google, Amazon, Microsoft, or any local cloud provider that you have chosen? And the second one, and this is the last theory slide that I would like to show, is this one. For which kind of application is serverless a good solution? It's for the typical business application. This is what serverless applications have, serverless platforms have been built for. They are not tailored to very specific use cases. Nobody would go on and do, I don't know, Bitcoin mining based on a serverless platform in a cloud like Azure. That simply doesn't work. So if you need a car like that, and this is the reason why I have this picture here, I am very sorry, you cannot go to Volkswagen or BMW or whatever and say, I need this car. You have to build it on your own. But that's no longer serverless. Serverless is commodity. So if you build a typical business or IoT application, something like this, then serverless might be a really nice place to be. If you build something very, very specific with very specific domain requirements, then you probably have to go down one level to platform as a service, or even go down one level to infrastructure as a service, or in very specific cases where you even need specific hardware for your solution, you have to build your own data center. So it really depends whether you are building a commodity solution or a very specific solution. And to make it very clear, I repeat myself consciously, serverless is for commodity solutions. And with that, I'm done with theory. The rest of the talk will just be demos. So I will lose PowerPoint and we will spend a little bit of time, approximately a good half an hour, building some functions and take a look at Azure, how Microsoft has implemented this functionality. What I have prepared here is, this is the Azure portal for those of you who are not that familiar with Azure. And this Azure portal here, I have prepared a so-called resource group. Here you see such a resource group. A resource group is a kind of, let's say, virtual data center inside of my Azure subscription. I can create resource groups for applications or for stages like dev, test, prod, or for customers. If you build software for many customers, then you typically use resource groups for isolating your different apps or customers or whatever you build. In my case, I've created a serverless webinar resource group, and I've created a bunch of things here that will go into more details later on in the demo. For now, I would like to add one demo. This is called a function app. Why a function app? Function apps, let's give the portal a second to come up. Come on, dear function app, show me. Yeah, here we are. Azure shows me that there is one kind of resource here, which is called function app. A function app is what Microsoft calls serverless apps. There are different serverless options throughout the Microsoft Azure platform. You have serverless NoSQL databases, you have serverless SQL databases, you have serverless container registries, you have a lot of serverless stuff. But in this talk, I would like to focus on serverless APIs and serverless microservices that I can develop in the programming language of my choice. And for that, I typically use in Azure so-called function apps. Let's select one of these. Let's select the function app and go on with defining such a function app. I will click on it now, and the Azure portal should, in a second, allow me to create my function app. Okay, so let's go on and create the function app. The screen is not responsive. It's not very responsive because when broadcasting a webinar, the CPU is heavily under load, so this is not the typical performance. This is how we live today when doing work from home, but I hope everything is fine and you can follow along. It's not that critical that it takes a little bit because we will talk a lot about the screen that we see here. Okay, I have chosen here my resource group serverless webinar, and I can choose any kind of name for my function. Let's say serverless live demo.websites.net, and this is the first thing that I would like to talk a little bit about. Let me zoom in a little bit so you get a better idea of what we do here. The first thing that I have to select is whether I want to build the Azure function based on code or based on a Docker container. These are the two options that Microsoft gives me when creating serverless function apps. I can just take my code, and you see the fully supported languages down here. I can take my code, compile it, and give it to Microsoft, and they will make sure that the necessary underlying infrastructure is provided accordingly. So they will spin up Windows or Linux machines. I can choose between Windows and Linux if I want, and they will make sure that the necessary runtimes are there and are properly configured. On the other hand, if I don't want to provide code, I can also go and build my own container images. And then I can provide the Azure function baked into a container image, and then I'm fully independent of what I do in this Docker container. I'm not fully independent. I have to provide at least the other function runtime, but I could even use a language that is not fully supported by Microsoft. For instance, I could write an Azure function in Go using a community project and bake that into a Docker container, and then I have a much higher degree of freedom. For our demo, I would like to use code, and I would like to go for .NET Core. 3.1 looks good, and I just select that I want to use the West Europe data center. That looks good. Let's go next step to hosting. The first one is fine. I will not talk about that. The next thing that I would like to talk about is, oops, sorry, I zoomed wrong. Now it should work. I have to choose whether I want to use Windows or Linux servers. It's called serverless. Yes, that's true. But still, I have to think about which operating system I would like to use. And you have the choice in Azure between Linux and Windows. I will now stick to Windows, but Linux works perfectly fine. We run Linux, we run Windows. It really doesn't matter. The last thing that I would like to talk about, and this will be something that is very important, is the Azure plan type. We have three different options for this plan type. Here you see the option. The first one, it's called consumption. Consumption means this is really serverless. Consumption means you pay for what you really use. If nobody uses your app, then you don't pay anything. If you have a lot of traffic on your app, you have to pay a lot of money, of course. This is real serverless. It can scale down to 0, and it can scale up to a pretty high amount of computing power. Consumption has one drawback. Consumption is like a rather slow heating system. So if you have a sudden burst in users that would like to view your, I don't know, latest cute cat video, everybody wants to view your cat video, then maybe the consumption plan is a little bit too slow. It reacts pretty fast, but maybe for you too slow. Because the first request that comes in will take a while, because if it's scaled down to 0, all that is left in the Azure cloud is a kind of reverse proxy that recognizes your incoming request, for instance, an HTTP request, and will spin up, cold start your services on the fly. And typically you don't want cold starts because they are rather slow. And your customers, they want to wait for cold starts. So therefore, Microsoft introduced a new plan type, which is called Premium. Premium essentially says, I would like to have a mixture of hotel, platform as a service, and electricity, serverless. It means that Microsoft will always make sure that a minimum amount of resources is reserved for you, and you have to pay for them, no matter if you use them or not. But they will always be up and running, so the chance of having to wait for a cold start is greatly reduced in many cases to zero, because there is always a little bit of resourcing reserved, and you can configure how many resources you want to have on stock if you want. If you need more, you get real serverless experience. Last but not least, app service plan. That's the third one. That's a fallback if you don't want to use serverless. App service plan is hotel. App service plan means, dear Azure, I don't want to care about operating system. I don't want to patch my web server. I don't want to think about load balancer and things like that. Care for domain name service and things like that. But I will tell you how many servers I want, how much CPU should be in each server, how much RAM should be in each server. This is what you have great control over. And you can, for instance, define schedules. So if you know upfront that every day at, I don't know, 6:30 o'clock in the morning, you have a big burst of CPU usage, then you can define a schedule and you spin up the necessary machines a few minutes before this burst in order to have enough available, okay? That is the app service plan. The app service plan is, as I said, platform as a service, and we will today focus on this one, serverless, okay? So let's get back and select serverless. I will not talk about application insights here because it's the monitoring solution and we only have 1 hour left, so I will not go into the details here. It's a great thing for doing logging, monitoring, and telemetry, but it's not the topic of today's talk, so let's skip it. Now we are done. This is all we have to specify. And please note that in this serverless solution, we didn't say how many servers we need. We didn't say how large the servers should be. We just told the system that we would like to use .NET Core, and everything else will be configured automatically, dynamically for us. Let's hit create. This will now create the function app for me. It will take a few moments, maybe a minute or two, to set up this function app, and then we can take a look at the function app and take a closer look at how it works. While this runs here, let me spin up a new web server and go to the Azure website, because at that point in the demos, I typically get the question, hey Rainer, if it's serverless and everything is dynamic, how can I estimate the costs? And this question is rather hard to answer, if not impossible. So let me, while this other thing is creating, show you the pricing. Let's go here to web, and then, oh, not here, to serverless. Where is serverless? Oh, I can hear. Function, here, Azure Functions. This is Azure Functions, and this is the business model that you have when it comes to Azure Functions. So if you ask me, hey Rainer, how can I calculate the costs of serverless functions? My answer is it's super easy to calculate. If you know exactly how many CPU milliseconds you need and how much RAM your app needs, I can tell you exactly how much money you will have to pay to Microsoft. But that's just theory, of course, obviously. Nobody knows exactly how many gigabytes memory you will use over the course of a month and how many CPU cycles you are going to use. So at the end of the day, you cannot really decide upfront how much your serverless solution will cost. You know the amount of money you have to pay for the multiplication of processor CPU seconds multiplied by gigabytes working set memory. And this is a 0 with a lot of following zeros and then a 1.4 per gigabyte second. So it's a variable pricing. The first 400,000 gigabyte seconds are for free. The first million execution is for free. Per execution of a function, you also have a little bit of price. So my experience in the last years of using serverless is that it's very hard upfront to exactly define how much money your serverless functions will cost. My real world experience is you have to test it. You have to build a prototype, or maybe you have an existing solution, deploy it to Azure Functions, generate a little bit of load. Either if you have already customers, just put a few preview customers on this machine and then try to extrapolate from that on. You have to measure, you have to collect telemetry, and from that on, you can find out how much money you will have to spend each month for your serverless infrastructure. So monitoring, telemetry, logging is super important when it comes to serverless because of pricing. Not only because of pricing, but also because of pricing. Additionally, optimization becomes sexy again. Because if you make your algorithms more efficient, you use less CPU, you immediately save a lot of money. If you, for instance, write a more memory efficient algorithm, you immediately save money. So you have short-term return on investments for refactorings, for optimizations. And that's an important thing that you have to keep in mind. The old thinking of let's buy a huge server that hurts one time because it's so expensive buying it, that is over. Now the controllers, the management team will take a look at the invoices of Azure every single month, and they will ask you, hey, can't we make our algorithms more efficient? Because then we don't have to pay so much money. So that's a very important thought. Keep that thought and remember it when you transition from infrastructure as a service or platform as a service towards serverless. So let's go back to our other browser, and yes, the deployment has succeeded. Everything else would have been a surprise. Let's go back to my resource group. Where is it? Here, serverless webinar, looks good. Here we are. And now we have our serverless live demo. This is now our serverless function. Let's take a look at this very simple example. It's essentially empty what we see here. Here you see on the left-hand side, functions. It's currently refreshing. There are no functions yet. We can do a lot of configuration stuff here. And I would like to zoom in a little bit and tell you a little bit about the configuration options that we have here in the serverless world. And afterwards, we'll go to Visual Studio and use a little bit of .NET to deploy a sample function app onto this function here. What you see here, you can do some app settings. App settings could be, for instance, some settings for applications, some connection strings to databases, or API keys for downstream backend microservices, things like that. It's important to understand that these function app settings are really tightly integrated into Azure's Key Vault. So please remember that you should never ever store some kind of critical secrets, plain text in function app settings. You should always store your secrets like API keys and so on in Key Vault, and then just refer from these function app settings to Key Vault. Unfortunately, I only have 1 hour of time, so if you are interested in this topic, please look it up in the documentation. There is a separate chapter about how to integrate Key Vault with Azure Functions. Just remember Key Vault, and you will find all the necessary information in the docs. A little bit of configuration and so on and so on. Let's talk about the networking stuff. This one, networking is important because it's super important that you are able to connect your functions in the cloud, for instance, with a virtual network that might even be connected to your enterprise network through a VPN, a virtual private network. So it's important to have the possibility to build hybrid solutions here. It's important to be able to add your serverless functions into your virtual networks in the cloud, to do DevSecOps, things like microsegmentation, making sure that the microservices can only access those microservices that they are supposed to talk to, and things like that. Also in the area of security are things like SSL, certificates, and so on, authentication and authorization, OpenID Connect, maybe Azure Active Directory integration, and things like that. I will not go into details because I only have 1 hour, but with these topics, you see what's possible, and you can check it out. You can check the details in the docs. Down here, you see the monitoring section. So when you run your application, you can use the built-in monitoring in Azure to gather logs, to take a look at log streaming. You can see every single invocation of your function. You can take a look where it came from, what was the originator, what did it do, did you have any unhandled exceptions and things like that. That's the monitoring section. If you implement a web API, you can specify Swagger documents, open API specification documents that make it easier that make these function apps more easy to consume for end customers. Also, things like course support is built in. You can always change the app service plan. Can you remember this was the thing with the serverless, premium, and app service plan with the serverless with PaaS mixed, and PaaS, this is where you can change the settings on the fly. So you can on the fly switch from serverless to PaaS, from PaaS to serverless, whatever you want to go. And last but not least, you have a bunch of development tools. Some of them I will show to you. So that's essentially the platform features. Unfortunately, we don't have enough time to go into all the details, but I'm pretty sure that you will find your way through this. We could now add a function here in the portal. We could use the Azure portal to set up an application, for instance, in .NET or Node.js or whatever. We can immediately set up continuous integration and deployment, but this is kind of, I always call it Harry Potter programming. So you have your magic wand and suddenly everything is done. That's not very interesting if you want to understand what's going on behind the scenes. So I will not use the portal for now. I will go a more deep dive approach. It's not a real deep dive, but it's beyond Hello World, and I go to an integrated development environment, in this case Visual Studio. But I would like to make very clear that you do not need Visual Studio in order to work with Azure Functions. If you prefer a different development environment, even just an editor like Atom or Visual Studio Code, you can do all the steps that I show you here in Visual Studio with the so-called function runtime. So if I spin up a command prompt here and I say func, you will see the function runtime that you can install locally. You will in a few seconds see the Azure function logo, and with this CLI, with this command line interface, you can do whatever you want on any platform fully in the console. If you want, you can use Vim and this Azure function CLI here to go fully without GUI, so everything is possible. But to be honest, sometimes having an IDE is kind of convenient. And for this demo, I can show you the concepts better if I stay here in the IDE. So let's start a new function from scratch before we switch to a pre-built sample solution where we take a look at more advanced features. But first, I would like to show you with a kind of Hello World application how these Azure functions work. So let me look up the project type Azure function here, say next, and let's put it, I don't know, here in my temp folder. That's fine because it's just Hello World. And you see, okay, I have selected .NET because I'm here in Visual Studio, but I repeat myself, choose any language that is supported or go for containers if you want to do something that is completely under your control. But I will stay here in .NET Core, independent of Linux or Windows. It works on both platforms. The first thing that you have to understand, and this is now very important if you want to understand Azure Functions, is that Azure Functions are not just regular HTTP or gRPC web apps. That's not the case. Azure Functions, serverless in Azure, does not only mean operating serverlessly, but it also gives you a programming model. So can you remember my slides at the beginning? I had this event-driven programming. This is built into Azure Functions. You are not using the regular ASP.NET Core web apps. You are not using regular, I don't know, Express.js for Node.js or something like this, but you use the specific Azure Function programming model, which is built for microservices, which are driven by events. And therefore, if I build a new function, I can always choose what should be the trigger of my function. Trigger could be an image is dropped into blob storage. Maybe a camera has uploaded an image and you now would like to analyze this camera. You will see that later on in my larger demo. Cosmos DB, a NoSQL database. MongoDB, for instance, would be possible here. I would like to trigger my function whenever something changes in my database. I can use HTTP, of course. If you have an incoming HTTP request, you can trigger the serverless function. You can connect it to IoT solutions. You can use queues, topics and subscriptions, or first in, first out queues. You can use timers and many, many more, because these triggers, you have a separate SDK with which you can even build your own integrations and triggers. For the first demo, I will go for the simplest one, the HTTP trigger. Here on the right-hand side, you see a very important thing here. It's the authorization level. And here you have three different options: function authorization, admin authorization, or anonymous authorization. For this demo, I will use anonymous, but the other twos essentially give you API keys plus the relevant management of the API keys out of the box. So Azure Functions has a maintenance of function API keys built in. You don't have to invent your own management of API keys. If you would like to use a more elaborate authorization and authentication scheme like OpenID Connect, you would go for anonymous, and then you would use the Azure portal that you have showed before to configure, for instance, Azure Active Directory integration for OpenID Connect, or you can use OpenID Connect and implement the necessary protocol inside your function. Okay? Again, I don't have a lot of time here. I will go for anonymous to keep things simple, but I wanted to make sure that you understand your options: API keys or OpenID Connect. Let's click on create, and this will now create the Azure function here in my Visual Studio. As I told you, my laptop is not the fastest one if I'm doing a webinar like this, because it's the webinar platform uses quite a lot of CPU power. I will wait for another few seconds. If it takes more time, I will switch to my pre-created sample, and we'll get back later on here. Okay, I don't want to wait so long, so I switch to my larger example to show you first glimpses into a more complex bundling of a function app, and we will go back to our function app that we built from scratch in a bunch of moments. So let's take a look at this example. This example, let me zoom in a little bit. You can find it in my GitHub repository. If you want to have a pointer, take a look at my reinerstropek.me URL, or send me an email or a tweet or whatever. I can show you the link in my GitHub repo where you can find this code. This is a typical, more advanced Azure function, and I would like to dissect it together with you. This Azure function is technically, as a developer speaking, just see it here, a C# function. Could be a node function, could be a function in any platform that is supported. But here, up here, you see the trigger that I selected. In this case, it's a more real-world trigger. It's not an HTTP trigger, but it's a service bus trigger. So in this case, I have a topic subscription model where I created a topic where consumers can send a message to, and my Azure function will automatically subscribe to this topic, and it will be triggered whenever a new message appears in this topic, and it will automatically trigger the C# function and do something with it. I don't have to write the code to connect to my topic and the subscription. In Azure, it's called Service Bus. I don't have to care for authentication and things like that. This is all done for me. It automatically triggers my function whenever an event happens. And this is what I mean with event-based computing. But in this case, the business scenario is that I would like to I described it a little bit wrongly. This up here is the return value. So in my case, the return value is sent into a topic. Sorry, I did this wrong. I had this wrong in my mind. So the return value is written to the service bus. The trigger is here. It's a blob trigger. You see it here. The business scenario here is that you have maybe an IoT scenario that wants to recognize images of cars that drive on a highway, for instance. So you have cameras, and whenever this camera detects a car, it makes a picture and uploads it to an Azure Blob Store, and this Blob Store will automatically trigger the function. You will get the name of the camera, which is extracted from the blob URL, and the name of the image here, from the blob storage, and then you can write arbitrary C# code handling this camera image. In my case, I'm downloading this camera image, sending it to REST API in the cloud, which is a machine learning system detecting license plates, and then I will send a message with the detected license plate into this topic. So the important thing here is that the Azure function, its core, it's just regular C# code, but I do not have to care for triggering the C# function because this is done automatically by the programming model of Azure functions. And I do not have to care that my return value is written into a platform, in this case, a topic that can then trigger the next function. So in my case, I have, for instance, here a second function, which is now triggered by the service bus. So I have a second microservice, which is triggered by the results of the first microservice, and this microservice will check whether the car has a valid vignette. I have a third microservice here, which will do some section controlling. It will also be triggered by this topic, and it will check whether the car has been driving too fast, for instance. So this is how you connect the functions. You do not have to write the glue code. You just write the business logic for each service or microservice, and the Azure Functions runtime will make sure that the functions and the microservices are connected properly. Okay, let's quickly go back. Yes, the function has been created. This is the function that is hello world. And as you can see, this one uses an HTTP trigger, a much simpler trigger than the one that I've shown you before. And in this case, I'm just building a response message responding with an HTTP response. But this hello world function is perfectly suited to give you a little bit of more information how this feels as a developer. So let's, for instance, set a breakpoint here and let's start this function. This is an important one because I can run this function locally in my Visual Studio without having to deploy it into the cloud. And the important thing here is that my function that I run here is starting up locally with full support of the debugger. So I remain in Visual Studio, I can set breakpoints, but I can still access the function through the internet. Don't get me wrong, my machine is not connected to the internet. But for instance, if I'm reacting on blob storage triggers and so on, they will still be triggered on my local machine. So the developer experience is really nice with Azure Functions. I can do everything on my local machine, but still I am connected to my Azure cloud for things like Service Bus and Cosmos DB and databases and so on. In this case, I will use my local web server. As you can see it here, it's running now locally. And I can go to my browser and say something like this, name equals Rainer, that's my name. And if I hit enter, I should hit my breakpoint in Visual Studio. And now I can step through this function in exactly the way that I'm used to. I have my inspection points, my watch points. I can take a look at the variables, continue letting it run, and here you will see the result of this Azure function, and it just works. All I had to do if I would like to deploy that to the cloud is either, if it's just a Hello World solution, publish it from Visual Studio. This is of course not the professional way. Friends don't let friends deploy from Visual Studio. That's not the way we do it, but for demos, it's fine. The other way is I could add continuous integration and continuous deployment, where I have build servers that build my function, run some unit tests, and then trigger the deployment from my build server. This is out of scope for today's demos. Or third version, I can also click here and add, for instance, Docker support to my project in order to build a Docker container image, and then I can use my own Docker image to run my functions. So this was the Hello World demo. And now let's take a look at the more advanced demo and let's run it so you see that it really works also in more advanced scenarios. I will set a breakpoint here in my, that's the wrong one, I'm sorry. I will set it here, process camera image. I will set the breakpoint here and start running my traffic monitor sample app. The C# code is not relevant. This is not a C# workshop. We are not talking about Azure APIs. I just want to make sure that you understand how these Azure functions work with triggers, how they are triggered, how they work together. Okay? So I press F5, and again, the function runtime runs locally, which enables me to debug all these things. And I've opened up here the so-called Storage Explorer that allows me to take the role of a camera. You see, this is where my fictitious IoT camera devices will drop in some images of cars. And of course, I have prepared some demo images. Let me show you these images here. Here they are. Of course, for a nice demo, I need a nice car. And in this case, you will see a DeLorean driving across the highway, and this is what we want to detect, this license plate here. Let's see whether it works. So let's see whether my debugger is already running. As you can see, everything seems to work nicely, and I will just drop here the image. So I'm simulating the camera detecting the DeLorean. Here in the background, you see the function runtime picks up in the cloud. This is running in the cloud. It picks up the blob store and it triggers my locally running debugger, although I dropped the image in the cloud. And now I'm here as a developer, stepping through my code and see that everything works fine. At the end, I will write something into a service bus queue, and that will, in the next step, add the trigger the section control microservice. So add a breakpoint here and let the rest of the algorithm run through. So remove the first breakpoint, let it run, and if everything works out nicely, it should recognize the license plate, write something into my service bus, and let's continue here, write something into my service bus and trigger the second microservice using service bus, no longer blob storage or HTTP. Let's give it a few seconds, and here we are. This check section control was now triggered by a message in a service bus. The service bus is running in Azure, but my local function is running nicely in Visual Studio. So I have my usual developer experience. I can step through the business logic, and I can let everything run through. In this case, the system will recognize the DeLorean driving into a section control, and it will check the average speed when it leaves the section control, for instance. Now, last but not least, and then we will open it up for questions so that we have a few minutes of questions. What happens if I need the help of a human? Here, for instance, I have pixelated the image, the license plate a little bit, so it's harder to read. So probably the machine learning algorithm will not do a very good job detecting this license plate. It will need the help of a human being. Now, what I did here, when I drop it in, I can show it to you. Here it is, extra blur. This will now be picked up by our Azure function, and I've set a breakpoint here because here we see the result of the machine learning algorithm. I don't know if you can see it. The recognition result confidence was 93%, but we said at least we need 94%. So this recognition was not done properly. We need the help of a human. And in my case, I have integrated Slack in order to ask a human being for help. And if I run this here, if I'm lucky and everything works out nicely, I should see in a few moments, let me get Slack up on the screen here. Where is my demo? Here it is. See, this one, Slack is now, oops, that was too fast. I will bring it here on the screen. Here it is. You see, my Azure function asks me whether it's okay and whether this detection was correct. Why did I integrate Slack here? Because the big difference here is that this is a long-running workflow. It could take minutes, maybe even hours for somebody to answer this question, approve or reject. And this is the last important takeaway that I would like you to take away from this webinar. Azure functions are not just for short-running workflows, but they support stateful serverless functions too. So they can save the state and make sure the state is persisted even though the serverless function infrastructure is scaled up, scaled down, and so on, Microsoft Azure will care for serving the state, for saving the state. And when somebody clicks on approve, for instance, it will dehydrate the state from its own storage mechanism, and you can program just like you would program a function that works without long-running workflows. But then with long-running workflows and all your local variables and so on, they will be automatically saved to Azure storage, and you can easily implement long-running workflows where you involve humans. That's essentially what I wanted to show you. Let me quickly go back to my slide and bring this one up, and this should open up the Q&A section. Quick recap. Serverless means there are servers, but we don't have to care about them. We focus on the business logic of our microservices, and we use a separate programming model, event-driven programming model, to combine the microservices. They will be triggered automatically, but we have still a very nice developer experience by having the ability to do some debugging locally. With that, I would like to spend the last few minutes that we have, I think we have 5 minutes left, and open it up for questions. If you have questions, feel free to use the chat. And I think also Peter is in the call still, and maybe he has some questions if we don't have any other questions coming up. Thank you so far for listening. And yeah, I'm open for questions.
I don't see any questions, but very thankful for the exciting overview about the serverless world in Azure. For me, I have one question on your. It's very interesting at the end to this state transfer. Is it means that a customer have a session that it always detect the same function, or it means another concept of state that you associate with a runtime?
Yeah, if you use stateful serverless functions, the function instance gets a unique identifier, a global unique identifier. And whenever you interact with this instance of the serverless function, then you have to pass on the identifier of the function. There are two different programming models for writing stateful serverless functions in Azure. One is the implicit state management feature, where you just use local variables, and the function will essentially run every time from the beginning. And what Azure does, whenever you access maybe some storage, or maybe you use some API features to I don't know, get a random number or something like this, you have to use special features. And these features, remember that they have been called before in this instance of the serverless function, and they will immediately return the result without duplicating the calls. So you can really program just like if you would have a normal function that is just long running. You can forget about handling state at all, and the platform will do all the magic for you. If you want to have more control about that, you can use a more actor-like programming model, where you have a stateful actor. Could be, for instance, an ID, maybe an order, for instance, where you want to gather data over time. Then you have multiple serverless functions, which are essentially stateless, but they get the identifier of the actor, and you can store data into the actor, and you can always access this actor in different serverless function instances. So these are the two programming models. One is really very implicit. Everything is magic, Harry Potter programming. The other is more explicit, where you manage the actors and the instances yourself.
And the other, many thanks, Eng. I understand this concept. It's a very useful one to migrate something that you before implemented as a big service to serverless world. That you can also handle some session-like actor state for a workflow or so longer time, and share that on different functions. The other question that I have is more, I think the complexity of algorithms don't go away with serverless. And
they don't.
That means you split your workflow in smaller pieces, and you have different functions, different queues between them, and so
Yes.
how you trace a workflow that is very complex, and how your development team is involved in code management of all these functions to get it together in a debugging or in a tracing world to manage some failures or what other useless things can happen in development IT.
Yep.
How you handle this case. It's very complex. No, it's also true for the current systems or other architectures, but it's also specialized on serverless world that you managed smaller pieces that are comes from one code base, I think.
Okay, I will try a short answer because we are already running out of time, but I would like to answer this question because it's super important. You hit the nail here with that. First one, it was rather quick when I showed the demo, but we had the notion of the function app. The function app is a bigger concept that is a collection of functions. So a microservice in terms of Azure functions is not a single function, but it's the collection of functions that logically belong together. So if you take a look in my Visual Studio, I have a bunch of functions, as you can see here, and they are maintained inside a common function app. So if you have a microservice, the microservice is not the function, but the function app. This is my first answer. So you don't end up with having nano services that you for every nano service you have your own, I don't know, Git repo or something. No, you don't work like that. That doesn't work.
That's a nightmare.
So that's the first answer. Absolutely. That's the first answer. Second answer, application insights. Application insights is the logging, monitoring, and telemetry platform. And application insights can in real time detect which function calls which function and where are the calls flying and so on. And you have powerful visualizations where you can take a look how the communication between your functions and function apps are going on and what happened where. Which function triggered which function, what happened there, and so on and so on. So telemetry, logging, and monitoring are the second answer to your question. And the third answer is a platform which is called Logic Apps. We didn't cover it here in this topic. It would be a separate webinar. Logic Apps are an orchestrator sitting on top of Azure functions, and they are there for orchestrating business level transactions. So maybe you have a business level function that has to call one microservice, then it has to call into SAP, then it has to call into Microsoft Dynamics CRM, and then it has to send an email back to the customer. So if you have a really complex workflow on a business level where you have to orchestrate multiple microservices, which might be Azure functions, then you shouldn't implement them in separate Azure functions, but you should go for Logic Apps. They have a built-in support for hundreds of software as a service applications. They have a graphical workflow designer, a domain-specific language for a state machine and things like that. And that will be my third answer. So function apps,
many thanks.
Logic apps, and the third one was logging, monitoring, and telemetry with application insights.
Yeah, it's a good point, Inge, that in a complicated work is a good answer for that. But new for me is that the applications, it's more a domain-driven thing like microservices and other deployments that people or a team can handle as a unit. And that is very important, I think, that you have this domain-driven design and have a good point in these applications that you can handle all your functionalities of one domain on one place in one project and handle that for a team. That's a great news. Thanks. Very thanks for this exciting speech to introduce serverless Azure function in the Azure cloud. Thanks.
Yeah, thank you for having me. It was a blast. And if you have any questions to all the viewers, also the viewers who will take a look at this and on YouTube, for instance, we'll put a recording on YouTube. Feel free to contact me. Feel free to link yourself up with me with LinkedIn, Facebook, Twitter, or whatever. Yeah, thank you for having me. It was a really nice hour.
Nice. I say thankful to all attendees and I say goodbye and have a good day today. It's sunny in Germany. Nice. Bye.
Bye.
So, jetzt ist stoppt. Hörst du mich noch, Rainer?
Ich höre dich, aber ich bin nicht sicher, ob du schon gestoppt hast.
Ich habe gestoppt. Bildschirmübertragung beenden. Es wird nichts übertragen. Also ich glaube, ich habe aufgehört.
Vielleicht ist noch jemand im Meeting, der uns Feedback geben kann.
Ja, ich höre euch noch, sagt der Michael Schmidt.
Genau. Ich nehme nämlich auch an, dass das Webinar noch läuft, denn ich sehe bei mir die Message, this session is being recorded.